students of underground coal mining methods MN 2102. Welcome to our 1 dozen class, that is a 12th lecture online MS Team on this 4th February. Sorry for little late because there was a power cut and then there is some problem in electrical connections. I think that computer was off. Now I restarted it. Okay. Now continuing with our lecture number 12, let me know whether my screen is visible. Is it visible?
Yes, sir, visible, sir.
Very nice. So now we will start with our lecture number 12. As we started with our module 1, where we try to see how this development and all takes place. And in the stratified deposit, then we started moving towards the development workings and board and pillar workings and all. In that, to continue further, how this there are different ways of the development. This can be an in-seam development or it can be a horizon mining. And in general, in-seam development, what are the suitable? You should be able to understand if some seam conditions or geomining conditions of the coal deposits are given. You should be in a position to have some idea, some inference from whatever we are reading, trying to discuss, which may be the best way of development and then deplering or extraction of coal with different type of methods. In that, now we will concentrate initially to board and pillar type of development, or in the development also there can be, as I told you, it can be in seam development or horizon, right? Development. And just to say, just for a simple idea for all, already you have that idea, I know that. If the seam is almost flat seam or gently dipping, right? Not very steep, like 1 in 1 or something like that, 45, 50, 60, something like that. Then what we do, we can enter either through shaft or through incline or decline, whatever it is. Then you can do development in the seam itself. You need not go for any type of additional development to reach the seam from a vertical shaft or somewhere else. Generally, if it is any shaft or any entry, it is better. Even in metal mines, what we do is on the footwall side in the metal mine, the deposit, right? Other in the floor side, it is better to go for a shaft or any entry. Of course, that can be planned in so many ways near middle of this. But if it is steep, then better to go along the floor side or the footwall side of it, so that whenever you are extracting this, even by without any backfilling methods or stowing methods, this, even if you are caving it, this your entry or the shaft or the incline, whatever is there, that will not get affected. Very simple to understand. Then if it is the surface, right, and then your seam is like this, in that case, how you are reaching, it can be by an incline like this, right? And then there in the seam itself, now you are having two openings, and then this is the way how we develop. And some of that regulation related issues also already we have discussed, are some regulation numbers even in coal mines regulation. This is the reason why I give you in between also, so that you can just simply write coal mines regulation 2017. Then in that also regulation number 111 are regarding even entry into the mine, even development of that, deplering, well, there are so many conditions, so many guidelines given in that. All those things we should know. Anyway, you will be reading in the final year as a part of legislation. But whenever it comes related to our methods technology, you should know a part of that also. That is the reason why I included even in the syllabus itself that understanding the coal mines regulation is important for us. Now, coming to this, that means when it is a flat seam, then in that way in seam development, that is in the seam itself you are doing development, not having any shaft somewhere else, and then horizon type of development where in the metal mines we do, it is not required. And where it's a free of faults, or it is a medium or high thickness of the seams, and seam density is low. What is the meaning of seam density low? The meaning is very simple. That means when there are seams which are very close, right? There are so many seams. Okay. So within 10 meter, within 20 meter, there are so many seams. Then density is more, right? Within 100 meter, there are 6, 7 seams. Otherwise, there is one seam, and then there is a parting of 200 meter, and below there is another seam. Okay, then you can work independently, because even this, if the thickness is less or medium, this effect may not be reaching even up to the overlying seam, which is at 300-meter parting or something like that. So this is the way how. Then workable with caving method, then shallow or medium depths, then mine lease area. All these things are also there in several books, but just for an idea, the review for you. Then when it comes to the horizon mining, that means it is very simple example already I told you. Almost all metal mines, whether it is a recently closed Kolar goldfields. You must be seeing KGF 2 movie also now. It will come, right? Oh, Dadi Baba hero hai usme. Okay. Then KGF 1, where it can be a gold mine, copper, lead and zinc, or whatever, manganese mine, which are extracted by underground mining methods. There generally we go by a shaft in the footwall side, in the metal mine or in the floor side, right? Wherein you can get connected, right? And this is called a horizon development. As we have a level at this place, another level here at 50-meter interval. And again, there are so many design criteria. All those things we will be reading, of course, in coal mines or in the metal mines, how all these things should be designed and what are the parameters to be considered. Now, levels in the rock parallel, don't worry for the spelling mistakes. Only I was typing it in between. Now, perpendicular to strike of the seam, then intake and return air at different horizons, right? In general, what we do is when you take the intake air, right? If it is a shaft like this, okay, then this may be serving as an intake air, or there can be another shaft which may be serving as a return, right, shaft, and then there the exhaust fan might have been fixed, right? Then here this may be going up to the bottom as intake, and then ventilating that that portion of the mine or the deposit or the workings, then it will be going up. And because why we frame like that, the air when it enters into the mine with the gradient, as a geothermal gradient, even that temperature also increases with the depth. Okay, and then when that becomes lighter, okay, it is always better to plan in such a way. That is a reason why I am telling you that the return air in the horizon, which is a little bit above, that this is the way how we plan for ventilation also. Then there are so many systems, of course, that you will be reading in the ascensional ventilation, descensional ventilation, so many things like that. Homotropal, like all those terminologies you'll be reading in details in the ventilation in another courses also. Now, secondary roadways are in the seam. Then locomotive haulage generally used as a main transport. This is the way how when it is a metal mine, especially we use, or even in coal mines also, especially in southeastern coalfield, we use a lot of locomotive haulage, electric locos, as you are having a train similar to that. All those things are also used. Now, in that suitable conditions, gradient of seam more than 15 degree, then Chasnala, Sudamri mines, we have with the horizon mining system where it is inclined, right? Munidi mine, this was opened up in 6 seams in quick succession. In that places they used it. That is example. Now here, before going further into opening out a district and all, because in the last classes there were a lot of problems, I could not show some of the videos, right? I am taking you once again to a mine inside where there are continuous miners used. Okay. Now, are you able to see anything on the screen? Yes, no.
Screen got blank.
Yes, sir. Video but not started.
Not started, right? Okay. So underground looks like this only. That's what I wanted to tell you. You will not see anything, but you should carry your own light. That's what I used to say. Okay. So now you see when you are going inside the mine. Okay. Now, are you feeling that you are there with me in this mine? Yes, no?
Yes, sir.
Very nice. Yeah, be with me. Don't leave me, right? मैं तो बुढ़ा हो गया ना, आप सबको साथ में लेके my Jaunga, I want to take you to the next generation mining engineers to take care of any underground coal mining situation, and you can plan for it. Okay, so now you see how this mine is appearing. They are going inside. Okay, how this lighting and then galleries on this side. This is in-seam development. In the seam, it is there, the development. And this whitish, why it is looking like this? Because it is whitewashed. It is not like your, but this is a stone dusted. Right, so some limestone powder and stone dusted. That's why it looks white. And there are so many reasons for that. One is even it gives, instead of black, it gives a good illumination, right? Then it is preventing the spontaneous heating uh, uh, capability of this coal also. That means if it is coal is exposed to air, then this is subjected to oxygenation and then spontaneous heating, fire and all. When you give some coating with some inert material, right? So that is the reason why they are divided into different dusting zones. You may note down, you may be learning in other courses, but let me tell you based on my this little 35 years experience, right? They make into zones, dusting zones, and it is supposed to be divided into 3 subzones, and each subzone once in every month when there is a regulations for that, it should be stone dusted. So that you are preventing any fires. Now you are going a little bit further. While going inside, you are trying to understand how these arrangements are made in the incline or in the seam or in the development workings. Now you can see where free street vehicles and are being moved, or otherwise you may think, don't think that you are running like this, right? But it can be going in the free street vehicle or something like that. Otherwise, it can be through some type of a track, right, where you may be going through mine cars. Other mine car is not your Santro or BMW car. That is also which can be free street vehicle. Otherwise, it can be through the rail system. Track will be there in that. Right. In that way, this is a man way. Now you can consider like that. And then how the lighting and all arrangements are made, you can see. Now you are going inside into the development workings. You develop it so nicely. You are maintaining so clean. I wish that when you are a manager, when you are agent, general manager, director, CMD, chairman, wherever in any country, you will be maintaining the mine like this. Right. Now continuing further. Right. I am taking you to the latest technologies what we are using in the board and pillar methods. That is a continuous miner. You please note down. So along with that itself, I will be telling something more about those things and some points I wish you should note down those things where now you can see here itself. I don't know whether you can hear the sound of this. Are you able to hear the sound in that? Now I put that sound on. Now, are you able to see the sound? You
No,
hear the
sir.
sound? Okay, then I will explain, don't worry. Otherwise, there is some sound also behind. Okay, so now we reached the place where now depillering is going on. This is a development, right? Now you are extracting it. Otherwise, it can be a part of development itself, no problem. But where continuous miners are being used, how it is there, now you just see how this continuous miner is working. Are you able to see something here being cut? Yes. Right. Now, little bit more. Yes. So now with the continuous miner, now you are cutting the coal instead of blasting this face. Okay. This is a latest technology as far as our, whether it is a development or depillering, especially in the board and pillar method of mine, not in long wall. Now we are discussing on the board and pillar, its development, depillering, design of that, even designing the panel, pillar size, how a panel should be designed, everything along with the manpower, transport, ventilation, all those things required for that. And now you can see how this is being cut. Now our person is there, and this can be sometimes wireless systems are also there to operate these continuous miners nowadays. Otherwise, it was a remote operated where person will not be there near the cutting phase, but a distance away from there, and then he is operating with his whatever is a lever or whatever arrangement for operating that, where to cut and then changing the height of the boom and then which horizon to be cut, all those things he will be doing that. Same thing with remote control LHDs also, load haul dumpers. Right? This is a remote control, even wireless control or with wire. Both are options available. That is the latest technology, my beloved students of underground coal mining methods 2102. And now little bit more you see. Now how it is being cut. This is a boom cutter, right? All cutting picks are there on that. After cutting this material is being collected by the gathering arm loader, which is there on that, and then it is will loading through some type of a conveying arrangement, like a chain conveyor, and then that is loading onto the shuttle car of different capacities, 10 ton, 20 ton, like. Then this is taken again dumped into onto a belt conveyor or some other arrangements for that. This is the way how this is whole getting operation is going on. Now you are able to see how this continuous miner is working. Is it fine? Are you able to see it? Yes, no?
Yes, sir.
Right. This is the latest technology as far as coal getting in board and pillar. Coal getting at the face. Otherwise, this was before just by hand picking when there was no explosive, right? When there was no blasting. Boom bol ke blast nahi karta tha, right? After blasting, this coal getting was through blast, and that blast also with a cut, right? That is only a cut of 10-15 centimeter, right? Where that is to provide a preface and then using instantaneous detonators, or there was no delay detonator. Then the next development was without any cut. That means a solid blasting was used, and where it is a solid blast, right? Where you are doing that without any making any cut, you are blasting with delay detonators. So these are the different technologies. Then later now we are using the continuous miners in the board and pillar. Otherwise it can be even road headers. All these things you please note down. And again road headers can be something like a drum type of cutter, otherwise a boom type of cutter with different arrangements are there. Now to continue a little bit further, now not that's why I wanted to show you something, since we are discussing about the board and pillar, what is latest happening. When you are cutting it like this, now you must have understood that when you are cutting and getting, now here we are getting coal about 2,500 tons per day. Now how to transport? So there should be a system, right, to transport that coal also. And now when you concentrate on the work that is going on at the face, then there is a cycle of operations required and number of persons required, manpower, all those things we will be discussing later, right? Then when you are doing this, after cutting, you can imagine when you are cutting, at least for about 1 meter, 1.5 meter, you will get around 20 ton of coal or 25 tons. To get 2,000 tons, now you can imagine how many meters of progress will be made. So when there is so much of progress, now you cannot keep that roof just like that in the development or depilling workings when you are doing that, right? And then what you are supposed to do, there should be a compatible system for the support also. That is the reason why mechanized bolting is also done. That also I will show little small clip before breaking for your doubts. Now let me show you. Now you see, my beloved students, when this is these are some another cutting whatever a different clip, how it appears when it is cut. Now you can see the way when you are cutting it and when it is a blasted face, there is a lot of difference. The damage to the roof, sides and all, there is no damage, no much damage I should say. I should not say no damage. Even when you are applying some force on anything, there will be some change in the state of that material. So obviously there will be some disturbance, but that will be very less when you are cutting it. Compared to when you are blasting, then there will be a lot of cracks and so many things. So this is the way of another clipping, it seems. It's okay. In this later, when you are getting so much of face advance, now you can see how after cutting how this face is appearing. Now that's why I told you, you are there with me now at the face. So when this space is created, now you have to provide the support, my beloved students of underground coal mining methods, right? What is that support? How it should be designed? All those things we will discuss in another, module. But for that, what is the recent technology available that I wanted to give you now? That recent technology available is now. Let me go to that as a little bit more. What is there? See how that face is appearing. I want you to see that now there. Don't worry. Now I am showing you how that bolting is done. Okay. Now you can see how they are doing this bolting operation, right? Now you see, yeah, there is some problem in this. Don't worry. We'll go for other. Don't worry for that. Then how this resin bolting we are able to do that. Now let me show that. Okay. Yeah. There are 2-3 clippings in that. Let me open. Yeah. Open with this. Now you are able to see. Now after cutting this, right? As a somebody should respond, then I can understand that you are hearing my voice and able to see. Okay.
Yes, sir.
Yes,
Right.
yes, sir.
Very good. Nice. So now you see how this bolting is done. When there is so much of advance required, right? Then we need a fast bolting machines also. You cannot have a simple conventional way of my person going or 3 persons in a timber mazdoor's crew, and they will be drilling hole manually with 1.2 HP, 1.25 HP motor which we carry. Even I used to drill when I am like you, taking training. I used to drill myself. I used to help them in blasting, charging the holes. Even I used to drive that LSD or SDLs, whatever it is, right? Also as a mission mining district in charge, also I used to do all these things. Okay, that is a different pleasure, of course. Now, here, how this is being done. Now you can see we have a mechanized bolting machines. How they are now you can see. This is what is the latest system and equipments what we use in board and pillar mining methods, where now you are able to use such a wonderful system where it has a self canopy. Here you are now you can see a little further canopies, and yeah, it is not here in this. Don't worry. Another clipping also I am showing you. Yes. Now you can see how our people are able to do this bolting and how they are safe, right? Now you must have seen by this initial stage itself, where already we have is some type of hydraulic ram and other things. It is at the cutting phase. After cutting, now you are providing. This is what is a cycle. You please note down somewhere. I am not writing everything here. One cycle means now your phase is given to you. Now you start cutting it or blasting this, right? That is a first operation. And immediately after cutting or blasting, now you should ensure that that roof sides, everything should be stable. So you should provide the support wherever it is required. And now they are doing this support. Support is the next cycle, right? After this support, right? Then only, even if in the semi-mechanized or in manual mining, after providing support only, your other miners other than supervisors are allowed inside. That is also a rule and a law, and also is supposed to be done for the stability, whatever it is, or safety of the persons. Now, here in that cycle now, after blasting, then before loading, you should ensure the stability of that working. Then you should support this, and then only you should allow other persons under the supported roof and sides. And you also please note down somewhere, my beloved students of underground coal mining methods MN 2102, that no person should be allowed unsupervised, right, except supervisors, because supervisors are supposed to supervise. and unsupervised, nobody should be allowed, and no person should work in any unstable roof or whatever the roof conditions. That means it is a responsibility of the supervisor or that manager. This is a technically manager is responsible to make that working safe through all this system of people. Okay. Now you see, to ensure that, now you can see how nicely we are having an arrangement of installing these resin bolts. Now I am playing this. That means before a person goes there, he is also making this temporary support with a hydraulic ram or whatever it is. After erecting this, then person is going below that. That means he is working under a supported roof. That is the meaning. Now it is supported with something like a four poling. That word also you must have heard somewhere. That means on other side there is nothing than four pole, like a cantilever, right? It is providing the support. Then person is going there, and then how they are doing the bolting, you can see mechanized bolting. Now person is standing here, then his canopy is there already over the head. So he is safe even if some part is getting collapsed or whatever it happens, right? Of course, it cannot withstand the total load of roof, everything, but if small portions, if it is coming down and all, that will be the protection. Now, continuing further, now you can see they are erecting these supports and these bolts. Now you see how this drilling is being done automatically. These are all automated. Now, with different number of booms. Now here it is a two boom where two bolts can be erected at a time. It can be three boom also or a single boom, whatever it is. And here, drilling is done in that cycle of supporting. First, we make the hole drilling, then clean that hole, and then insert the rod, and then your cement or resin, then allow it to settle, and then provide that if it is a pretension bolt, then give that pretension. Otherwise, you can provide with a nut and assembly so that you are installing the total system. Now you can see how it is done. When this is drilling is over, now that rod is out, and now bolting rod is kept inside, and now they are putting the resin capsules inside, and the nut and bolt is also placed into the spanner. Now you see in the spanner that nut and bolt, it is there with this. Now it is spinning this bolt, right? Then already that resin was inserted in the beginning inside, and now that resin, which is there in the form of a capsule, now that gets broken. I mean, total mixed with that total material, right? Now it sets within no time, within few seconds. Now what is happening? Now after particular time, now here there is some type of arrangement where there is a shearing pin, right? And then now after that predefined setting load, it stops. It will not move further. That means now we can ensure that that much of load is already free. So this is what just I wanted to show. And before breaking, just let me make it a short. This one, yeah, here also you can have a look of it in a very simple way. Yes. That is a mechanism of this resin bolt, how they are doing it automatically, how it is being done. This is that shear pin. Okay. When we are rotating it, what is happening here now you can see with a nut and bolt how it was done. Now, first, this resin is pushed inside. This will be more clear, my beloved students of underground coal mining. Now, after this 1 minute, I will break it. Now you can see nicely how it is being demonstrated. Now it is pushed inside, and later after then resin is released, and then Nut is there with the bolt. Now you can see how it is moving. This nut is there with the bolt through the shear pin, and that is rotating, right, through that socket of that drill machine, whatever. Then now you can see this is a bearing plate, and now you can see after it reaches some type of setting, right, maybe 10 ton, 15, 20, 25, even people claim even up to 50 tons of anchorage. But unless we test, we cannot ensure that. But we are able to test up to 25 to 30. So we can at least assume that much. Now, what it is happening after setting, then then we, instead of this total assembly rotating, only this nut will rotate. Then it shears this pin, and then now this bolt, now it is done. See, this will be releasing this nut now. This shearing happens, and that releases the nut. And this is what is a mechanism of setting that. Now you must have seen. It's sufficient for you to explain how this is a latest system what is followed in any mechanized, when you say method with resin and continuous minus. So this is what just I wanted to show for the time being. Now we are going back into that. Let us take your attendance also, and now let us break for just 1-2 minutes for your any doubts, please. Let me take attendance meanwhile. Right. Any doubts? Then after 1 minute, then I will continue. Meanwhile, you decide yourself who will be doing is whatever summary later after 10-15 minutes. If any doubt, you can ask. If there is no doubt, I think attendance is downloaded. Now I am going back into
Sir,
our. Yes, please.
sir, in sim development, in suitable conditions, you told that it should be free from faults. So
Right.
sir, I wanted to know that how we detect the faults without seeing it.
Very good. Nice. Any other doubts? Any other doubts?
Sir, where we use their bore instant detonator instead of delay detonator, sir?
Instantaneous detonator.
Yes, sir.
Now, generally, when we are doing with already there is some preface, right? If there is a preface, then if that preface is sufficient, then there is no need of any delay detonator. Delay detonators are required to prepare the preface, right, for subsequent row or round. That means now you just imagine this is your face, okay, working face, or this is your 4 meter by 3 meter. Okay. Now what we do is, now if you are loading this with 1.5 or 1.8 meter length, I am showing like this, and then your holes, if these holes are up to a depth of 1.8 meter, now you can imagine, right? When you charge with explosive of around 10-12 kgs of explosive, you can also calculate how much energy and so many things, gas energy and shock energy, so many things, right? That you will be anyway learning in blasting technology, another course also. Now here, that much of explosive when it is blasted, right? Now that energy will be released through so many ways. Now that energy will be going partly on that side, partly on this side, partly on this side, that side, 360 degree, right? All around. Whenever there is a preface, now what happens? All that shock wave or these things from the preface that gets reflected. When that is getting reflected, that till that preface it is going as a compressive wave, and from the preface when it is a 180-degree shift, when it is returning back, that means that becomes a tensile wave. In tension, rock is weak or in compression? Very simple. Any layman can tell. Any rock, coal, whatever. In tension, it is weak or in compression?
In tension.
Very simple.
Sir.
This is also very simple. Before exam in tension, you will become very weak. Your father will feed you with so much energy. बहुत कुछ बादाम खिलाएगा, पिस्ता खिलाएगा, ठीक है, एग्जाम के टाइम में पढ़ने से. But the same thing. If you are under tension, you will fail. Same way. So now under tension, right? Tensile strength, you may note down somewhere. You will be learning in geomechanics, rock mechanics also later, or stator control technology also in final year, where any rock in general is almost having a compressive strength, suppose X, then its tensile strength may be 1/10 of it, X by 10, right? And its shear strength may be 1/3 of it, right? Compressive strength. And when it is, this is a sample strength. When you are getting a sample, now I can show. I used to keep the samples with me. This is for stator control technology class. Okay. Now since I am talking about the sample and compressive strength, tested compressive strength material of different size, I am showing you, my beloved students. My India के पीछे से ला रहा हूँ. Don't think it is from any other country, from our country only. India like a पीछे है, लेकिन हमारा country का है. Right. You see how this is tested compressive strength. This is of course with the triaxial test we conducted for some other purpose. Right. These are different rock sample. You can see sandstone samples of different kind. Right. So that means what I wanted to tell you is when it is subjected to compressive strength, if it can take some X load, when it is subject to tensile, it can be broken at almost 1/10 of that much of load itself. You understood. Under shear, only 1/3 of it. And this is a sample strength, sample, but this is not the strength in the rock mass in the field. That may be almost 1/5 to 1/10 again, right? These are the things that you should know about when we are designing. Also, it will come that time. Also, I will show you how pillars are designed. Yes, any other doubts? Somebody asked some other doubt.
Yes, sir. So I wanted to know how to detect the faults without seeing it.
Very good. So now generally what happens during exploration stage itself, right? I hope I have shown you some plans. I don't know. Yes, I have shown you some plans, right? Mine plans also. Let me just, it is 108. Somewhere some plans also were there. Yes. So now you see, this is a total mine. Now this is based on the exploration data before. If there are some faults, for example, suppose there may be some fault here. Now it is there, but it is not very clear. Is छोटा है, बहुत बड़ा करके देख सकते हैं. ठीक है. So there are some faults here, fault here, right? So this can be based on the exploration data. And many times what happens, coming to your doubt, now this is a seam, right? If it is continuing, now I started in seam development, I am developing it. Okay, developing, this is a seam. But instead of that, this is seam, this is totally seam. But here, this seam from here, it is thrown down by a fault, 200 meter down. Now I cannot continue extraction or the in-seam development. It is better for me. Now again, you may have to have some shaft or something else and get connected to that and then develop, right? Instead of that, if it is clubbed with that, when it faults or something like that, better go with some type of horizon development from here. It may be separated by different fault. I hope you understood now. Okay.
Yes.
Continue further, right? That is the reason why in between I used to show all these plans and everything, right? Yes, now we are there here. Where we are? Yes, development. Okay, so in this horizon development and all right. Now it is 10:53, at least 5 minutes more, let me discuss. Any doubts or shall I continue? And now, how to open a district, right? And in general, district means this is a number of pillars you select, 10 pillar, 20 pillars, 5 levels, 6 dip along the dip or 5 along the level or whatever. Generally along the level, this is more size. right? That is for the convenience also, where along the level it is easy for any machine to move compared to in the depressed direction. Very simple, right? So now how to decide that my district size or panel size should be of this much, right? In general, when it is opening also, I told you at that time. So in general, people are doing, people did before our forefathers. It is starting from the main entries, right? Then they were going from the part to the whole, right? From here itself, I start extracting. Now I can show you like this. This is a total mine. All these are pillars. Are you able to see this keyboard? Yes, no. Right? These are all pillars.
Yes, sir.
Okay, this is your mine. Now you imagine there are no pillars, only you made the development through two inclines or otherwise a shaft, and then starting developing it and then opening different districts. Now that means what? From part to whole means now I reached through shaft here, otherwise through two inclines like this.
Sir?
Here. Yes.
Sir, move up a little bit, sir. It's not visible actual keyboard now.
Not visible. Is it visible now?
Moves up, upward.
Yes, sir. Move it upward a little bit.
Move it
Acha,
upward, sir.
little more. Acha, acha.
Yes,
Yes,
sir.
sir.
That's
Yes.
ठीक है.
Now it's
I
visible,
was
sir.
just trying to show that this is totally mine. You just imagine to incline I entered, otherwise to shaft, and then from part to whole means from here I start developing all these pillars from the beginning here itself, and then going like this. That is a part to whole. Otherwise, from the whole, that is instead of developing these pillars, what from the main entry, what I do is I make only trunk roadways up to the boundary. This is my boundary of the deposit. On this side, this is all 4 kilometers, this side 3 kilometer, whatever general size. Then that is from whole, that means I am reaching up to the boundary, and then later I will decide my panel size is of 200 meter by 200 or 300 by 200 meter size. In that, then I develop and then depillar. That is the best way. Simultaneous development and depilling. This is what we have to do it. And in the beginning, you must have understood why they used to do like that. Very simple. When you are going from part to whole, this is easy for as a manager. You will be getting lot of coal near your development working itself. Right. Otherwise, from whole to part means I should drive up to the boundary, only two trunk roadways, laying your whatever water pipeline, and then providing ventilation up to that much distance, and then providing transport arrangement through endless hauler or whatever it is. So many things, right? And then you start extraction. Then that takes a lot of time. But it is from part to whole. From the beginning itself, we are getting so much of coal by development, making into pillars 20%, 15% of coal is available. Right. That is the reason why at that time people used to prefer as a manager, when you are given a chance, you may be going with part to whole because you will be getting a lot of coal in the beginning, showing as one of the best managers producing so much coal. But that is not the way, or not the way of good planning. Okay, that is not allowed nowadays. Right. So now later when you reach up to that, so this is your panel, for example, right? Panel size, I decided after entry from whole, reached up to the boundary through only two trunk roadways. Then I decided this is a panel size of 10 pillars or 5 pillar, 50 pillar. Otherwise, 5 pillar here or 4 pillar here, 20 pillars. This will be my district size. Then how you are deciding? Based on the incubation period. You note down for today that much, right? If the incubation period is 6 months, 8 months, and the technology, with all that, then you will be deciding. Then based on that, now you will be opening out the district. And for that, in any new mine, a set of headings is driven in the deprise and level directions. Districts which consist of a number of coal pillars are opened from such set of headings. The manner of opening being primarily already, as I told you, mode of entry, either shaft, incline, then type of transport. Now you are going with a rope, direct haulage, and then endless haulage and tugger haulage. There are so many things, right? And then otherwise a trackless, you can have even a shuttle car and something else, or if there is a decline, even up to surface, you can get that through mine cars itself, or so many things. Then gradient of the seam. Otherwise, it can be a, I have not written here, but it can be a conveyor transport, which is not here, but you note down. Then gradient of the seam, whether it is a flat or steep, then you will decide even orientation of the workings also. Even the dip, instead of having a main dip, you will have an apparent dip. So that if it is a dipping like this, even that seam, if it is dipping like this. Now, I think for board and pillar, I should use this. This appears like a board and pillar development, right? So it is dipping like this. Now, when you are having depressed gallery, it is so inclined. Instead of that, what I do is, I will not have in the main dip direction, true dip. Otherwise, I will have apparent dip. Pillars will be rhombus shape like this. I can do that, right? Then its inclination will be compared to the true dip, it will be less, so that my machinery can work better. This is the way how rhombus shaped pillars are. These type of uh, workings in apparent dip are also supposed to be done sometimes. Now here we will stop for today. Tomorrow again we will discuss so many things about the opening the districts and then working. Now you can decide yourself if any doubt, otherwise within a minute you can summarize and close for today. Yes, my beloved students. Who can summarize? I am taking attendance meanwhile. At least fortunately we could not face any problem of disconnectivity or anything or power cut, which happened for your seniors in when I was taking strata control technology class, which is a lucky number. That's why that power gone. I think 13th class for them. For you, it is 12, 1 dozen. 1 dozen is a good number. एक dozen केला तो खाना चाहिए. Right. So now any doubts? Otherwise, who is ready to summarize? You start summarizing.
Sir,
Anybody?
Ariman. Sir,
Yeah,
am I
please
Ariman?
continue, Arman.
Yes, sir. So we started our lecture by learning about the horizon development or the in-sim development. In that we learn about different suitable conditions, like in case of flat seam, that is you told us that extraction can be done preferably from the footwall side of the flat seam. It can also be done in the incline or decline or using a shaft. The shaft is generally not necessary, and in the second conditions are free. It should be free of faults, and then you told us how to detect how to detect the fault, and other conditions are medium and high. It should be medium and high thickness. The seam density should be low. That is, the seam should be continuously spread, and it should be workable with different caving methods. Then in horizon mining developments, the features are the main road should be level irrespective of the gradient of the seam. The levels of rock should be parallel or perpendicular to the strike of the seam. Intake or the return of air should be present for proper ventilation. Secondary roadways should be present in the seam, and locomotives or main transport systems should also be there. Now, in case of suitable conditions, you told us the gradient has to be greater than 15 degrees. And in example of mines, you told us about the Chasnala mines. Then you told us that in some videos you showed that there are different zones present in the coal. So each zone is divided into 3 subzone, and um, to protect it from spontaneous heating, each zone must be stone dusted in regular intervals. Then in another video, you showed us the depillaring of mine. So rather than blasting, we use cutting methods. Now, immediately after cutting for stabilization and for safety purposes, roof bolting was done using mechanized roof bolting machine to provide support wherever it was necessary. It has self canoping, and it has a resin capsule, cylindrical in shape, and it usually get crushed when we drill it inside. And then we learn about the development in board and pillar mining, specifically opening of a district. it generally consists of lot of coal pillar mines, a lot of coal pillars. So the primary development depends upon the four things, that is mode of entry to the seam, types of transport system to be adopted, for example conveyor belts, and gradient of the seam, and nature of the coal, that is the heating nature. Thank you, sir.
Very good. So today we also tried to see some of these whatever cutting latest technologies as far as board and pillar mining is concerned. You have seen these are the continuous miners and even the resin bolting. This is the latest technology as far as depillering is concerned, and that's what just I wanted to tell you. All the best, my beloved students. Now for today, I think we can close. It is continuous miner and resin bolting, the latest technologies, how it is being used. And that is with remote, but wired remote he was operating it. Otherwise it can be wireless also, as you are able to see how it is cutting. And then with a wired one, a person is cutting this, is the operator of continuous mine. All the best for today and take care of COVID-19. You are living with I mean, uh, with your parents, right? You are living with your parents, right? They are living guards for you, right? Take care of them. They are already taking care. And Aryaman nicely summarized. Aryaman का profile pic बहुत बढ़िया है जी. Very good, nice. All the best. Now I am stopping. Before stopping, Jai Hind, Jai Bharat बोलना चाहिए.
Jai Hind, sir,
Right.
Jai
Jai Hind,
underground
Jai Bharat.
sir.
Now I am
Jai
stopping
Hind,
it.
Jai Bharat.
And anytime if you have any doubt, don't feel shy, except when I am sleeping. Other time you can discuss anytime. And of course, while I sleep also, you can write through email, WhatsApp, whatever. Okay, then all the best. I am stopping for today.